Alright, we're back with a little update here. The last video, I'm not sure where I was at, but I think I had to work on the vaporizer. So what I did here, and I'll bring you in to show this a little bit better, but what I did here is I installed the hydrogen system. This is the bubbler tank. This is what holds the water. Got a little bit of KOH in there. You can use other things, but I use KOH. What that does is it gets the um, it's a base, but what it does is it makes the water more conductive. So the way a cell works, a hydrogen cell, is electrolysis, is you have two plates, which we have multiple, but these are actually pipes. But anyway, the concept is you have two plates, and voltage jumps across those plates. And one plate facing the other plate, one side will be negative, one side will be positive. So the negative and positive jump that distance between them in that fluid, which is the water with KOH, and it needs to be distilled water. It's going to get muddy. Anyway, there's lots of videos on hydrogen systems that I've done even, but on my hydrogen system, you'll be able to go back and look and see how I did my hydrogen. Nothing different here. So I got I think about 8 amps, something like that, on my cell, which is about where I like to run between 5 and 10 amps. I like to have the water hot enough so that I can run 10 to 15 amps, and then I can turn my PWM down. So you'll see the PWM here. It's a voltage controller. It works on the PWM circuit. So it actually controls the ground side as well as the positive. But it uses the ground side to regulate the PWM cycle, which also means that you can't have your cell grounded to the frame, to the ground. It has to be a floating ground. And this has to be hooked to the ground. So you have to put insulators around the cell to mount the cell to something that's grounded. Anyway, we did that. That's fine. So we got a relay coming off our battery that supplies the so this is the wiring circuit. Battery to the relay, relay to the amp gauge to the PWM, and then from PWM power out to the cell, and power in obviously, and then ground over here and ground to the cell. That's all hooked to the PWM. We got our plumbing done. We can see how many amps we're pulling. Once we set this, we pretty much leave it alone. So I can come out here, adjust this to whatever amperage I want, and then shut the hood and go about my business. And it's just going to continually produce. What I'm doing is I'm hooking up the switch to this wire, which is from the switch inside the truck. So when I turn the ignition switch on, this wire gets fired up, and this wire is actually for my fuel pump, my electric fuel pump that I added. You see the custom wire here from an old extension cord that was in the back of my truck. So that's perfect. That's what you want. So yeah, anyway, so I'm going to use this wire for my switch to turn on voltage for this hydrogen circuit, so I don't have to put a switch inside the truck. I know it's on when the key is on. That's the way I want it. If I ever want it to go off when the key is on, I'll just unplug it right here from this relay. The relay won't kick, nothing will come on. So that's how the hydrogen setup is. And you see over here, I've got the base gasket made. I've got the base sitting on there. I still got to put the top screen in to tighten that base down, because that helps hold it. It's like a big washer that air can flow through that holds that base down nice and tight. It seals up that new seal we made for the bottom of it. But yeah, anyway, we'll be assembling that and putting the fogger together, and I'll be doing that next. So stay tuned for that. That'll be coming up. Okay, so hopefully the camera will focus here, but I just wanted to bring you in a little bit closer so you can see the circuit. That's a PWM board in there. A little hard to see it, but anyway, that's a PWM. You can see we got our variable voltage adjustment on top, which is just a pot. Anyway, we got a relay, PWM, and amp gauge, and that's the whole circuit. I've already gone over that. Then you've got your tubing comes out of the bubbler. That comes down, goes through the firewall, not the firewall, but the radiator support, and then comes to the cell. And you see the output on the cell is at the top, and the return line to the cell is at the bottom. What that does, the return line is this line right here. This is lower in the tank, so there's more pressure here than there is here coming out of the top of the cell. And you also notice that the water level is above the output from the cell. That's just in case when you've got your output coming out of this tube right here, and somebody pulls the output off, let's say, and they got, oh, what's this? I wonder if that's hydrogen coming out of there. And they get a lighter and they go, dink, boom. Well, what booms is going to be this. But you don't want it to travel down those lines to your cell and blow the cap off your cell. So some cells are made different, and when you do that, the cell itself might be destroyed. My cell wouldn't be, but we want to prevent that. So the next thing we're going to be doing is putting our vaporizer on here, getting that hooked up. I've already got the wires run. You can see our vaporizers are sitting here just dangling, and get ready to put them in, but that's plumbed through the firewall inside. So I'll be hooking this up inside the truck and mounting the circuit board in there so I can control that. And we're about to have the vaporizer built. I've got the new vaporizer built over here. I made an extension on it. The housing used to be this long. I added that extra length so the float actually doesn't stick out. Now the float sits behind the opening slightly, and our new piece for the floats, this is the float. The new pieces for the vaporizers, the 6 vaporizers will sit there, and they'll sit. So you can see I slide this in the front. It hits that float, it can't go any further. And that's going to keep them centered, and it can rotate as the water sloshes side to side, and it can go up and down with the water level. So they're going to be riding right there, and the water vapor is going to come straight up, and I'm going to be putting the hydrogen input right here. So I've already got that marked. Got to drill and tap that for my fitting, and then we'll go ahead and put this in, put the cap on the front. Now unfortunately the cap has to be removable, so what I'm going to have to do is put my rubber boot over this cap once that's put on there, and tighten up the clamps, and that'll hold water from being able to leak out of this cap. So it's going to be clamped here and here, and that'll prevent water from leaking. I'd like to have a rubber cap on this end, and I may be able to do that later, but right now I can't find the right size cap. So when I do, I'll probably replace it with that, because it's a little bulky having that on there, but it'll work for now, and it's what I have. So that's what we're doing. Then we've got our intake runner done. Filter goes right here. This is actually a sight window. I haven't taken this apart yet to slide the sight window in, but that's the sight window right here. So we got a piece of acrylic, clear acrylic, that we're going to be sliding inside of there, so we'll be able to see through in the chamber as the, so this is going to be our pickup, and this is where the fog is going to come in. This is going to be our input from the filter, so air is going to flow across. So we're going to be able to see through this window what's coming out of here. And also, eventually, we're going to be adding LEDs and probably lasers and maybe some high volt. I don't know. We're going to be adding some stuff up here, but for right now, we just want our fog to come up and be able to see the fog through the window. And this will be our window. Alright, so we got that all cleaned up, painted up, ready to go. So it's not so obvious that it's just a PVC pipe. And we've got our foggers ready to put in. We got our cell mounted, we got our cell hooked up, it's working. And we're about to do the fogger, vaporizer, whatever you want to call it. And then after we get that done, we're going to take off this plate right here. It's hard to see because I don't have a light down there. But I'm going to take off this plate. Maybe I can get that there. Well, anyway, it's just crap light. But I'm going to take that plate off, and then I can get to the side of the injection pump right here, where I need to turn the injection pump counterclockwise a couple flats with an Allen wrench. Flats on an Allen wrench. That's how far. I'm not turning it complete turns because that would be ridiculous. But we're probably already running lean. I don't know how many turns I did originally. I didn't keep track. But we're already at 22 miles per gallon right now. So at 22 miles per gallon, we've got to have multiple, probably at least one turn on the counterclockwise on the regulator, fuel regulating screw, Allen head screw inside the injection pump. But yeah, we're probably already as lean as we need to be, but I'm going to keep on going until I can get it to where it's running good, doesn't overheat, and it's as little fuel as possible, and it still runs. So that's the goal. That's what we're doing. And on the next video, we should be putting that vaporizer together. Okay, so we had to do a little modification here. I had to go ahead and shorten the front of this so I had more room in the back for the hose to come over to the reservoir. And I went ahead and purchased a black cap, rubber cap for the end here. So what I did is I shortened this, which gives me more room between the fill neck on the power steering pump. So I can slide this over the flange now. And it's just one clamp. And it's tight. So I won't have any leaks out the front, but I can open it up to get inside. And also, I shortened the foam piece inside with the little vibrators on it, so that, anyway, I shortened that so it fit, and I've got it all hooked up so it can move back and forth about a ½ inch, 3/4 of an inch inside there. That should be okay. I'm going to go ahead and put my clamp on, and then once we get this tight, I want to go ahead and fill it up with water, and okay, that should be good. Now it's going to sit about right there. So I'm just going to let it sit there. I'm not going to go ahead and put that on because I want to see what's going on inside, and if I have any issues, I want to be able to adjust that now. If I need to make those wicks shorter, whatever it is. So I want this to fill up, I want the float to shut off, and I want to see how much water this is holding. Okay, so we've got everything assembled. I've got the hydrogen system
working. That comes on with the key. I'll turn on the fogger, and once I start the engine, I'll turn on the fogger. So we're at the point of starting the engine and seeing how it runs with fog and hydrogen. So I'm going to go ahead and turn on the ignition, make sure it's in neutral. Sounds like it's in neutral. Grab our starting fluid here. Kick up the high idle. Okay, I just wanted to get inside so you can see I've got this operating, all six operating, and we're at idle. We're at a high idle right now, but I have all six foggers working right now, and it's probably four of them that are working because I had an issue with a couple of them. But what we're going to be doing is we're going to be paying attention to our temperature. It hasn't even started to come up yet. It's still running on high idle circuit. But we're running all the fog and probably about a liter of hydrogen, liter per minute. So after the truck warms up, I'll go ahead and shut off my fog Now you can see when I was looking in the window out there that the fogger was actually producing fog. I could see the fog in the window. And it may not have showed up on camera, but I could see the fog going across the sight window in there. So I know it's producing. And I've got it turned all the way up. The engine is running fine. Temperature hasn't moved yet, but we're going to give it some time. So I'm going to go ahead and give it some time, and then we'll come back to it. All right, we just pulled up to our gas station. We're getting ready to do a mileage test. I've got the hydrogen working. I've got the fogger working. Speaking of which, shut it off while it's not running. So I'm getting ready to fill up. We're not worried about how much gas it takes to fill up. We're just gonna, and it probably won't take much. It's probably half a gallon. I haven't really driven it since last time I tested it, except for back to my house. So I'm gonna go ahead and fill it up, and we're gonna do a 35-mile test, and we're gonna come back to the same pump, do the same thing, and see what it takes. So. Okay. So it took 2.864 to fill it up. I didn't do it like I normally do. This time I went ahead and filled it up so that I could see the fuel in the filler neck. It takes forever to do that. I like it when it just shuts off because then I know the tank is full and it's shot back up in the fill neck. But this time it was so close to being full. You can see it took over 2 gallons in that fill neck. It's a long tube, so anyway, I've got it filled up where I can see it in the fill neck. So now whenever I come back, I got to do the same thing, and it's going to take a little while to get it, but hopefully my battery doesn't die before we're done. So turn on our Waze app, get that going, and we will be able to see what our miles per hour is, since this doesn't have a speedometer hooked up. So just hit home. Now hopefully it's on mute, but I won't know until after I start driving whether or not it starts yelling at me. Okay, let's go. Alright, hydrogen's on with the key. I'm going to go ahead and turn on all of the foggers. That's how we're going to run it on this test. All the foggers are working. Maybe. I think 4 out of 6 are working. Maybe more. We'll see. So on the last test, we got 22.75, something like that, miles per gallon. So on this test, we're hoping for more, obviously. Seems to be running good. $55 miles an hour. Everything looks okay. Temperature is about 192. So I don't expect the temperature to get up over 195 with all this fog. I imagine it's going to be pretty cool. I actually had the fogger shut off driving up to the gas station. I'll do it because I wanted the engine to warm up, and it did take a little while to warm up, so I wanted to make sure that the engine got up to operating temperature before I turned on the foggers. So anyway, we got all 6 foggers working, and we're putting out at 7 amps on that cell, which should be putting out about a liter a minute. So that's basically what our initial test is going to be based on: 1 liter per minute of hydrogen, and all 6 foggers putting out whatever they're putting out. And like I said, probably 4 out of 6 are working. because these foggers have a wick, and the wick has to get saturated in order for the fogger to work. Sometimes you splash water on top of the fogger doesn't work. So foggers are going to be temperamental. But if I have some foggers that I can't make work, I'll go ahead and replace them with new ones. But hopefully we're not going to have to do that because I have to rewire the foggers. I have to solder the wires together, so I look forward to that if I have to do it. Not that big a deal, but I got to take things apart. Temperature's still about 192. Things seems to be okay. I'm not noticing anything weird. I can tell a little bit of a difference in the way that the engine is running, and I'll attribute that to the hydrogen more than the fog. It has a little bit of a different tone. It's hard to describe, but I can tell because I've driven this truck for almost 30 years. And I'm noticing something. I don't know what it is, but I am noticing something. So anyway, just cruising down the road. So our first test could have been flawed because maybe the fuel. That's why I use the same pump. You know, when your pump shuts off automatically, you use the tank that's full and it backsplashed, and that shuts your pump off. It did that, but I've also had those pumps do the same thing when fuel couldn't get down into the fill tube quick enough. And sometimes you got to do it a couple times to make it flow. But this time we didn't have enough fuel in the tank, we had too much fuel in the tank. It was basically full, so it shut off right away. So that's why I went ahead and filled it up into the fill net where I can see the fuel sitting in there. And it takes a while because that fuel wants to flow, and that shuts it up. Plus it has to settle back down. Ambulance. So the only thing we have done with this test is add hydrogen, approximately a liter per minute, and fog. We're using all of the fog. And temperature is just steady at 192. Temperature outside today is about 75 degrees. So this truck should be running at 195. That's what it generally runs at. But things seems to be going good. So I was watching a video earlier, and I saw someone, it happened to be a 7.3 IPI like this one, and he was talking about ECT temperatures, and I think he misunderstood what's going on. What he was talking about, the reason I watched this video was I couldn't remember if it was clockwise or counterclockwise to make it rich on this fuel distributor. And turns out clockwise makes it richer Counterclockwise makes it leaner. So he was turning it clockwise, and they use an Allen wrench. It's 5/32, I think, or 5/16. I don't know. It's a small Allen, and they count the flats on the Allen. So you got 6 flats on the Allen wrench. So one full turn would be 6 flats. So 3 flats would be half a turn. And 3 flats is generally what they do when they're making it run richer. And they say any more than that, you're just wasting fuel. But what he was saying was, he was worried about the exhaust gas temperatures being too hot as he was turning it clockwise, which was richening the mixture. So I think he just has a misunderstanding, or I misunderstand. But what I'm getting at is, when you lean an engine out, you make it run lean, it's going to create more heat. A lean combustion will create more heat. You can see that on spark plug. The guys that race, they pull the spark plugs out to see if it's running rich or lean, and also to see their timing. I'm not sure how to read the spark plug as good as these guys that are professionals, but I do understand a white plug is running hot. A gray plug is running about the right mixture, not too lean, not too rich. That's about what you want, is a gray plug. And a black plug is obviously running rich, and you probably got oil. If diesels had spark plugs, they would always be black, because diesels create a lot of soot. Well, anyway, what he was saying was, he was worried about his temperature, so he put an EGT gauge on his truck, which I think is really cool, and I may get one for this just so I can see how lean I'm getting and what my temperatures are, and give me a little bit more information than just engine temperature. Now, obviously, engine temperature is going to come up the leaner that you get, but also you don't want your EGTs getting over a certain temperature. And I think somewhere that guy said, which he must have done some research, he said you don't want them getting over 1,600 degrees. I think aluminum melts at lower temperature than that. So you definitely don't want them getting that hot. But my theory is, and manufacturers have been doing this for years, so it makes sense to me. They add more fuel to keep the EGTs down. The excess fuel that's not burned acts as a coolant in the combustion chamber that helps to quench some of the temperature out of the combustion. So your excess fuel has to be taken care of with your catalytic converter. And a portion of that comes back into the intake to get recycled so that they can meet their EPA standards. Which, by the way, thank you, Mr. Trump, for eliminating a whole bunch of crap that the EPA has been putting out for decades. I understand we don't want pollution, but there are ways to do that without making it so hard to make power. You know, I mean,
make the burn more efficient, do things like what I'm doing here with fog, hydrogen. There are ways to clean up an engine besides smogging it down. And all the other stuff, like the 5.4 with that BBT, camp, phaser, bull crap. Come on. I've been working on a 5.4 for my son. We put heads on it, we've done everything. Timing set, you name it. We had that thing apart 3 times, 4 times, and we still got issues with it. And that's because they're trying to meet EPA standards. So they're messing with timing. And the bad part is our TART engineer, or engineers, the whole group of them probably, came up with this idea to use oil pressure to regulate timing. Oil pressure should be there to keep you from spinning the bearing, keep things lubricated. That's the only thing oil pressure should be used for. And it should not go through a timing circuit before it gets to your cam, let's say. I mean, if you're... Anyway, get me started on that 5.4. Biggest piece of junk they ever made. And it sucks that engineers don't have to be mechanics first. They don't have to work on the engine that they make. So why would they care if the mechanic has to have 30 special tools to work on the piece of crap that they made that's going to fall apart? Maybe the manufacturer likes it that they fall apart. I don't know. But it makes sense to me that the manufacturer would want it to fall apart, because then they can sell you another vehicle. I mean, unless you're so pissed off that that vehicle was such a piece of crap that you won't buy another one. But apparently people are pretty brand loyal, and they'll continue to buy pieces of crap from the same manufacturer. I'm not that brand loyal, but I am brand loyal on this Ford. I'm not brand loyal with Ford because, like I said, the 5.4 is the biggest piece of junk I've ever worked on. So sometimes you get lucky, and you have engineers that make something that works really good, it's really dependable, and that's what I look for. I don't want to have to work on it. I want to be able to jump in it, and hey, if I need to put something in here for fuel that is not EPA approved, I want to be able to do that. And I want the motor to be able to burn it, to be able to utilize it. And I can do that with this engine. I can burn detergent in here. They used detergent in World War II in this same engine that was in, a version of this engine that was in the Deuce and a Half. And, they couldn't always get fuel on the front lines in Germany, or in France, or wherever they happened to be. So they had to use whatever they could find to make the trucks run. They needed troop transport, equipment, weapons, or whatever. So they need those things to run. And a lot of times they didn't have decent fuel. And the good thing about the diesel engine is it burns things with a low cetane rating. So it's a slow burn. It is not a very combustible liquid. So basically straight oil, other than being thick, the viscosity is too high to really flow unless it's heated up. But used motor oil that's been thinned out works just fine. So, if I had to, I don't know, I've got hundreds of gallons of vegetable oil that needs to be cleaned up that can go through this engine. I've got probably 100 gallons of used oil that can go in this engine, transmission fluid. So I love that I have an engine that I can put just about anything in and drive it. I can be stranded in the middle of nowhere, find a farm somewhere, get some gallons of used motor oil, throw it in the tank, and get to a gas station, and it'll be fine. Now that might clog up my filter if I use it too much, if I didn't have to clean or whatever. But the engine will burn it. As long as the pump will pump it, the injector will spray it. The motor will burn it. Now if you get gasoline in that, well, if you get too much gasoline in it, you'll get detonation. But otherwise, the motor will burn it. So our temperature is up to 193. We got all 6 foggers lit up. Whether or not they're all working, that's another story. Won't know that unless I take it apart and look at it inside there, unfortunately. It would be nice to have a sight window where I could look straight down in there into the fog chamber. But that'll be a different design later on. Maybe I can make a clear chamber where I can see the fog production. I can see each one of them and see if they're all operating or only 4 of them are. But those are improvements. First, we got to find out if we're making an improvement. If this is doing anything. And then we can always improve our system. But the first thing we got to do is make sure that everything works the way we hope. Now, this mileage test, I don't expect this mileage test to be much better than what I did for the baseline. I think it'll probably improve a little bit, maybe 3 to 5 miles per gallon. That's my guess. But we already had this fuel adjustment screw leaned out quite a bit because we were getting 22 to 23 miles per gallon. Unless that was just a bad test, which is possible. We're going to find out. If we get less than what we got before, we're going to have to rerun our baseline test. And we're going to have to run further than 35 miles. I do 35 miles because that just happens to be a loop that takes me back to the same place. Make 3 left turns, and I get back to the same place. But yeah, so we'll find out if the first test was good or not. Then we'll know going forward whether or not the hydrogen and fog improved our mileage from our baseline without changing the fuel. Now, I can tell by my temperature it's actually dropping. It's 192 now. Maybe all 6 foggers are working now. I don't know. But anyway, it's quite a bit of fog. Now, I showed earlier when I first started this through the sight window. You can barely see the fog moving through there. There's a ton of air moving through this engine. So the amount of fog to the amount of air of CFM is still pretty low. Maybe between 1% and 5% is probably about what we're doing. Going a little slow here. Speed up a little bit. So, as far as volume of air goes, the amount of hydrogen and fog that we're putting into the engine is minimal. So I'm kind of surprised to see that we're running at 192. It actually looks like it might have dropped even a little bit more. So I'm giving her a little bit more gas now. Try and heat it up a little bit more. Go a little faster. So, depending on what happens with this test, I can shut off the hydrogen, I can shut off the fogger, I can do another baseline test to verify, but I really need a fuel tank that I can fill up and I can see the level. So I may have to do something where I put another tank in the back, fill the tank up, and be able to see exactly how much I'm getting in there. The tanks on the truck, like I said, have fill neck. You can't see in the fill neck, so you know right where you fill it up. But it's not ideal. On the longer test, whatever, if it shuts off a little early or a little late, overall, it's not going to make much of a difference. But on a shorter test like this, at 35 miles, it needs to be more accurate. So, but then that's why we're swinging for the fences too. Big changes are obvious, and fine tuning your fill method and stuff like that is okay when you're making small improvements. But when you're swinging for the fences like we are right now, 45%. That's our baseline improvement. Our baseline improvement over stock is 45%, according to our last test. And that's probably because we're already running leaner. Even though I did turn it back out when I took that system off, I turned it back out until I could floor it and I saw black smoke. So I knew it was getting enough fuel where when you floored it, it was going to put out black smoke. As far as where it is actually adjusted to from stock, I don't know. And I don't really have a good way of knowing that. So, more than likely though, at least 3 flats or half a turn, in or out. I guess it would be out. It doesn't be counterclockwise. And I must be a half a turn on I guess it's the fuel proportioning needle. I don't know. I'm not sure. I have never taken that apart to see exactly what's going on in there. But I do know that there's a screw that goes in or out, and it changes how much fuel is going through the injector. Whatever you call it, that's what's happening. Railroad tracks. Now, this truck is so low geared, I just slowed down to 15 miles an hour. I'm in fourth gear. Now I'm in fifth. I mean, this truck, it's 410 rear end, 411. And the 5-speed is granny low in first gear. It's just granny low. You don't walk next to the truck in first gear. And in fifth gear, 55 miles an hour is almost 2,000 RPM. And I've got the tallest tire I can find on the back, 235. 235, 85, 16s. So they're a tall tire. I guess it's 31 and a half inches, 31 and 3/4 inches tall. I've got it as tall a tire on there as I can find. Now I could go ahead and order some tires and pay $200 a piece for them or something like that, and get 4 new tires for the back of this truck. But I ain't doing that. So it runs a little bit higher RPM. I just run slower. 60 miles an hour is about 2,200 RPM. And this truck can handle 2,200 RPM. So, yes, I would love to have it at 1,800 RPM with a 265, 85, 16. But I'm not spending $800 or $1,000 for 4 tires put on the back. It's lucky it's got tires that hold air. So I'm going to go with that. But if I was doing a long test, a long drive, I would prefer to have a taller tire just to keep the RPMs down and make it a little easier on the motor. But this motor can handle it. I've had it 2,500 RPM for 12 hours straight, and it handled it. So, you know, I think that was probably 500,000 miles ago. Probably doesn't like it as much now. But hey, you know, it ain't making any racket. So apparently it's somewhat happy. That old boy needs some more timber. He needs to push his chair back a little further from the table. Or something. That was unhealthy. Not that I'm a big health nut. That tree's going to fall down on somebody. But, you know. Are you freaking kidding me? Don't worry, I'll get out your way. You do you. giving her the beans. But she sounds good, and I did not see any smoke. And I was giving her the beans there. I wouldn't say I was 3/4 throttle, but still it was quite a bit. More than I normally would. I usually love this truck. She does need an oil change. Oil pressure is a little low. And I checked the oil, and the oil on the dipstick left a little to be desired. Of course, it's black diesel, but it was also pretty thin. So I'm doing oil change before I do any long range tests or anything like that. I mean, this truck, it should be happy that it's got oil in it. I'll tell you, I have taken care of my truck, don't get me wrong. But, you know, it's not a princess. This is not a princess. This is a brute. It's a brute that'll take whatever you give it and keep on trucking. That's what you want, you know? When I was a young guy, when I bought this, almost 30 years ago. No.
Now that I think about it, I was 28 years old when I bought this truck, and I've had it for 28 years. I've had this truck half of my life, and I've been driving it half of my life. I haven't been real nice. I've let the oil run low. I've over-revved it. I've put ugly, nasty vegetable oil in here that had fat and acids and junk. All I did was filter it just so it wouldn't clog up my injectors. Doing 2,400 RPM, 66 miles an hour. So 2,500 RPMs gets us up to 70. She's rocking and rolling right now, let me tell you. Our temperature is about 196. Running between 23 and 2,400 RPM. So, I mean, that's, for this truck, that's almost wide open. But it did bring the temperature up a little bit. Now, normally, if I was doing that without the fog, we'd be up around 200. And maybe we're 196. So, I'd say she's doing all right. As far as I can tell, it's happy with all the fog that we're putting in. And it's not affecting the temperature as much as I thought it would. But we're getting pretty close to our filling station. It's what they used to call gas stations. We're getting pretty close. Right up here at the top of the hill. So we're about to find out what's going on. Did we make an improvement? Anybody got a guess? Anybody put it in the comments down there. Tell me. Before we fill up now, don't cheat. I knew it was going to be worse. I knew your first test was bad because you didn't fill it up in the fill tube because this or that or whatever. I know. We'll do better testing when we need to. But what do you think? It's going to be an improvement? It's going to be the same? It's going to be less? Alright, fogger off. Alrighty. I think you can see that. Should be alright. Let's find out. Oh, you like it now, huh? Oh, now. Oh, I see. Nope. Alright, on the hard part, it's going to be this thing. What are we up to now? 1.2. Alright. So that's where okay. So 1.285. Now, if somebody wants to figure that out right 1.285. So 35 miles, 1.2. 1.285. Well, 1.285. It's an improvement. It's an improvement. I can't think right off the top of my head exactly what that would be. 1.285. It was 1.5 something last time. So, what is that, another 10%? 35 miles, 1.2. Let's say 1.3. So 26. I'm not sure. Okay. Well, anyway, it likes the fog. It likes the hydrogen. It seems to be getting better mileage. We haven't turned the fuel screw yet. So I think it's time to get a better testing tank. I think it's time for that. So it might be time for that, and it also might be time for a longer test. But I'm going to go ahead and lean it out for the next test. I'm going to go ahead and lean it out half a turn and do another test the way I did this test, and see if we can get better mileage than what we got this time. I'll figure that mileage out, and I'll update this video with the mileage after I figure out what it is. Okay, so we finished up our test, and I went ahead and wrote it down. So I'm going off memory here. I may have to check the video. But according to my test, the first time we had a baseline 22.786. Let's say 22.79 or 22.8, however you want to figure it. That was without hydrogen and without fog. This time we had all the fog and all the hydrogen. When I started out, the hydrogen cell was putting out about 7 amps, around a liter per minute. By the time I stopped my test, the hydrogen cell was up to 15 amps. So full production and probably a liter and a half a minute. When I shut the truck off to fill it up, it was running fine. I shut the fogger off. When I started it back up, I turned the fogger back on and took off, and I did notice a little bit of noise, maybe pinging or something like that. So I shut the fog off, and the noise went away, and then I turned the fog back on with just 2 foggers working, just minimal, and the pinging went away, but also my oil pressure's low. I need to change the oil. I need to put good oil in here, because I will be doing more tests. So the results probably already know, but my calculator tells me that we're getting 27.24 27 and a quarter miles per gallon. So we were at 22 and 3/4. Now we're at 27 and a quarter. And we haven't even adjusted the fuel yet. We do need to do better testing. Obviously, the testing method is flawed. We all know that. We know already. But like I said, we're swinging for the fences here. We're making major improvements, not small, 5% or something like that. We're talking 50%. It's more than 50%. It's not quite 50%. 27. If the truck got 15, we're not quite 50% right now. And 22.78, 22 and 3/4 was probably 40% or something like that. I thought it was more, but I haven't figured out a percentage. The truck's baseline mileage should be 15 miles per gallon. That's what this truck gets, every other truck like it gets. And if you turn that fuel up to roll coal, you're going to get 13. Maybe 10. Depends on how much you turn it up. We're turning it down, and we're getting better mileage. The temperature did drop, actually. So after I filled up and turned in to come home, the temperature was back down to 190. So truck's liking this. It's liking the hydrogen, and it's liking the fog. It might be liking it too much. I don't know. We're going to find out. Maybe we need to lean it out some more. So anyway, as it stands, 27 and a quarter miles per gallon, the best we can tell. We could do a longer test and use the same tank and maybe come up with a little bit different result, but it shouldn't be that much because we did the initial test. I just did the click method. You put the thing in there, you turn it on high, it flows until it gets a splash back, and then it shuts off. And that's generally how I fill up anyway. It's accurate enough over a tank of gas, but maybe not as accurate as it needs to be for a 35-mile test when you're only getting a gallon and a half of gas or less. And as these tests go on, it won't even be a gallon. So I need to be more accurate. So I got to figure out a fuel tank that's somehow visible in the back of the truck. So that requires some plumbing and other stuff, which I wasn't looking forward to and I really want to do. But I think it's probably necessary to continue doing the testing I'm doing in order to get more accuracy, because I know that a lot of people right now are probably saying, well, there ain't no way he's getting 22 miles a gallon. Or 27. That's what we're getting now. Find me another IDI 7.3 Dually crew cab that's getting 27 miles per gallon. I don't know of one. So other than mine, I don't know of one. 25% is generally what you can get doing hydrogen or doing fuel heating, vaporizing fuel. That's about where you're going to be. 25-30%. That's pretty common. And I've done both with hydrogen and really didn't get much more. So there seems to be a plateau that's hard to get past. But once you start removing fuel, once you remove as much fuel as you can for the engine to stay running, you've reached your plateau as far as that goes, unless you're replacing fuel with something else like I am with hydrogen. The fog is helping with a little bit of power and cooling, but the hydrogen is actually replacing whatever fuel I'm taking away. So the combination of those two should be good for this truck. We'll find out. I'm still not anywhere near where my tests were before, which would make this look like chocolate. I there was more going on though. And, you know, there's still a lot of things that I don't have on here that I did have on here then. And this is the first test. So the hydrogen cell had to warm up. It had to clean out. I haven't looked at the water in here, but it's probably pretty brown. The hydrogen cell had been sitting for well over 10 years. So, you know, could have a mud dauber nest in it. I don't know. But there was definitely trash coming out of it when I got it working. So yeah, it's not ideal. It's not a new cell. It's not completely cleaned out on the inside. There's, you know, it's old stuff that I'm using. But so far it's looking like we definitely made an improvement with adding the hydrogen and the fog. We'll have to do some more testing on the fogger. I need to actually see if all of the foggers are working, and it may be that it started pinging, or I don't know, sounded more like a rattle. And that rattle, normally that's what you get if you put starter fluid in there or something like that. So it's pre-detonation. Um, it could be that the hydrogen was just turned up too much. And maybe I need to locate the hydrogen control inside the truck. I wasn't going to do that because I wanted to control it from out here, but I can extend the potentiometer into the truck and leave the PWM out here if I need to do that. So, I mean, that may be something that I do so that I have more control, especially when I'm on a long drive. If I start noticing something going on, I can turn the hydrogen down. You know, I just figured I'd have it so that it only puts out so much hydrogen, and it shouldn't be too much. But I think at 15 amps it was probably too much. And plus, I don't want to be pulling 15 amps. You know, I don't really want to be pulling 15 amps on the alternator all the time. So, you know, 10 amps is fine. You can handle 10 amps. That's only 100 watts, 120 watts. So, you know, that ain't gonna hurt nothing. But 150 to 180 watts. Now you're starting to put a little load on the alternator. And it's 60 or 100 amp alternator, but just because it can doesn't mean it should put out that much. So, as it stands, I think we've had a pretty successful second test. I'm happy with the results. I'm more than happy that the results were better this time than they were last time. There was an improvement. Last time the baseline test was already a major improvement on what this truck gets from the factory. So we're already starting out with pretty major improvement on mileage. So getting more on top of that, it's tougher, you know. So, but we've seen an improvement, about 5 miles per gallon, 4.5. That's pretty significant. So as we turn the fuel down, we should see even more results, good results. But I definitely want to have the oil pressure up, get some good oil in it before I start leaning it out. Because if I am getting detonation, or if I am getting exhaust gas temperatures that are pretty high, I definitely need the lubrication. So I'll change the oil, put some good stuff back in it, and the next test we do, we'll do with 3 flats probably, turned counterclockwise, I believe, to lean it out some. We're going to go 3 at a time, and we'll test the mileage just like we did this time before I do a fuel tank in the back. But basically what I want to do is I want to find my plateau, and then I want to switch to vegetable oil. And I may add lasers back in. I may add LEDs. I'm not sure yet. I like how it looks in the sight glass with the LEDs anyway. I mean, I like to be able to look under the hood, especially at night, and see that thing lighten up, and also it kind of allows you to see the water vapor going through it. So I kind of like that. So I probably will add some type of LEDs inside of here and some lasers. Um, and we'll do a test and see if that made any difference. More than likely, it won't make a difference. And the other thing I could add that I'm not sure yet, but I could add high voltage. Um, there's reasoning behind the high voltage and the lasers and the LEDs, but that reasoning is, I'd be pretty skeptical of that. I don't know. I don't know if they add any benefit or not. I know it has something to do with electrons, spins of atoms and electrons, and how they want to recombine, things like that. Mainly because of the hydrogen. What we're putting in there is a really reactive hydrogen, and it's always wanting to recombine with something else. So that's why that's it's a possibility. But we'll look into that in the future and try and improve on our 27.25 miles per gallon. Thank you for watching. Like, subscribe, and keep up with this. If things keep going as well as they have been, we'll be doing a long trip pretty soon. So stay tuned.